Okay, ready to dive deep.
Always.
Today we're tackling tides.
Tide.
Yeah, but not the kind you're thinking of. You sent in these Miles Mathis articles.
Oh, right, right. His stuff is always out there.
Definitely makes you think. He's an independent researcher, likes to challenge the mainstream science.
So what's he saying about tides then? Different kind of tide pools.
Basically, he says everything we think we know is wrong.
Bold statement. Gotta love that.
You and me both.
Yeah.
But he makes some interesting points, like starting with the moon.
Okay, yeah, the moon. Everyone knows the moon causes tides.
Yeah.
Gravitational pull, right?
Right, but Mathis is like, hold on a second. He points out the sun's gravity. It's way stronger.
Stronger. Like how much stronger?
179 times stronger. So if it were all about gravity, why aren't the sun's tides, like, massive?
Huh. Never thought of it like that. But doesn't the standard model have an answer for that? Something about distance?
Yeah, they use this thing called the inverse cube law. It's like the closer an object, the stronger the pull, but also the rate of change matters more over that distance.
Rate of change. Like a steep hill versus a gentle slope.
Exactly. So the moon being closer, its gravitational field changes more drastically over the distance to Earth. That's supposed to explain why its tides are stronger.
Makes a certain kind of sense, I guess.
But Mathis isn't buying it. He says they're forgetting something big. Earth is moving, constantly orbiting the sun.
Ah, so it's like measuring that hill slope while you're on a roller coaster. The numbers are all messed up.
That's what he's saying. He thinks that completely changes how we should be calculating the moon's effect, so the standard explanation kind of falls apart.
Okay, so traditional model debunked. What's Mathis's alternative then? Anti-gravity tides.
Even wilder, he's talking about electromagnetic charge fields.
Charge fields, you mean like static cling, but on a planetary scale.
That's what he's proposing. And get this. He thinks what we call gravity is actually a mix of gravity and electromagnetism. Newton's equation, he says, lumps it all together.
So he's splitting them apart, like separating salt and pepper.
More or less. And the weird part is, he says smaller objects have stronger charge field density.
Hold on, the smaller things are more powerful. How's that work?
Think about it like this. You've got two balloons, one tiny, one huge. Rub them on your hair to get static.
The small one zaps you good. I get it. More concentrated charge, less surface area.
Exactly. So the moon, even though it's smaller than the sun, could have this super strong charge field.
Okay, I'm following. But
Yeah.
how does that make tides? Is the moon magnetically pulling the water up?
Nope. He says it's pushing down. This charge field acts like a repulsive force, creating a dip under the moon.
A dip. But wouldn't we see that all the time then? A giant dent in the ocean wherever the moon is?
Ah, that's where things get really interesting. Remember, Earth's spinning and the moon's orbiting. Plus, we got continents in the way. All that affects how this charge field actually plays out as tides.
So it's not just simple push and pull. It's like a whole choreography.
Exactly. And next time, we'll get into how Mathis explains those weird extra high tides and the differences between the hemispheres.
Sounds like a plan. Can't wait to see where he goes with this charge field stuff.
Me neither. It's going to be a wild ride. So last time, the moon's pushing down on the ocean. Charge field, not gravity. Still wrapping my head around that one.
It is pretty well,
Ah,
right?
yeah.
But it explains a lot of things traditional theories can't. Like, remember spring tides, those super high ones, and neap tides, the low ones.
Vaguely. Something about the sun and moon lining up.
Yeah, but Mathis's model adds a whole new dimension. Remember how we said the sun's charge field is weaker because it's bigger?
Right, like the balloons. Big one, not so much static.
Well, the sun's not completely out of the picture. It's got this solar wind thing going on.
Solar wind, like a breeze from the sun.
Not quite. It's a constant stream of charged particles. And when that hits the moon's charge field, things get interesting.
Interesting how it, like, blocks it.
It can actually amplify it or partially cancel it out. Depends on where everything's lined up.
So when the sun and moon are on the same side,
Boom. Extra strong push, super high tide. Same thing if they're on opposite sides, actually. Their forces combined.
but when they're at right angles.
The solar wind messes things up. The push is weaker. You get those low neap tides.
So it's like a cosmic tug of war. Sun, moon, solar wind, all fighting over our oceans.
You got it. And that brings us to another mystery. Deep water tides. How does the moon affect water miles down?
Yeah, it's not like it's stirring a giant pot. The force can't reach that far, can it?
Mathis says those aren't actually being cooled from above. They're compression waves. Like drop a pebble in a pond.
The ripples, yeah.
That's what's happening, but on a huge scale. Moon pushes down, creates a wave that travels all the way to the ocean floor.
And then bounces back.
Exactly. That's why they happen in deep water, too. It's not a pull from above, it's a push from the surface.
Mind blown. So what about those super high tides, like up in the Arctic?
Mathis has an answer for that, too. Backwash. Remember, the moon's making depression, then water rushes back in.
Right, right.
Well, up north, lots of land, lots of ice. The water has nowhere to go.
Hits a wall and bounces back, making it even higher.
Exactly. And because the Atlantic is kind of squeezed, those backwash tides are even stronger there.
Makes sense. What about the southern hemisphere, though? Tides are weaker down there, right?
Mathis says that's because the oceans are more open, the force has more space to dissipate, like dropping that pebble in a lake instead of a puddle.
The ripples fade out quicker.
Exactly. Only in places where the water's constricted, like around New Zealand, do the tides get really big.
It's wild how everything plays into it. The sun, the moon, the continents, a whole cosmic dance.
It's a beautiful system. And Mathis's theory ties it all together so elegantly.
Definitely makes you think. But what about the moon's effect on other things, not just water?
Oh, he goes there. And it's even wilder. Mathis thinks the moon's charge field might be affecting the weight of things here on Earth.
Hey, the moon can make things heavier. Now that's just crazy talk. Wait, heavier? You mean like I'd weigh more if the moon was right above me?
That's what he's saying. This charge field, it's not just pushing on the water, it's pushing on everything.
Nah, I don't feel heavier when the moon's out.
It's a tiny effect. Super tiny. We wouldn't notice it normally, like fractions of a gram maybe,
So when the moon's overhead, it's like a little extra gravity.
basically. Adds to Earth's pull. And then when it's on the other side of the planet,
Wings are lighter.
ever so slightly, it's like this constant subtle fluctuation
Yeah.
tied to the moon's position.
That's so weird to think about. Like, I'm walking around and my weight's changing based on where the moon is in the sky.
It's a pretty mind-blowing idea, right?
Huh.
But it makes sense. If you think about how this charge field is supposed to work, it's all connected.
Has anyone tried to actually measure this? Seems impossible. Like, how could you even tell?
Yeah, it'd be super tough. You'd need crazy sensitive instruments and
Yeah.
got to control for all the other stuff that affects weight, like air pressure. Even nearby mountains have gravity.
So it's more of a theoretical thing for now?
Pretty much. But Mathis thinks it could be done with the right setup.
Man, if someone proved it, that'd be huge. Like, our weight tied to the moon? It's like cosmically humbling.
Right. It really changes your perspective, makes you realize we're not as separate from all that stuff out there as we might think.
This whole Miles Mathis thing has been quite the journey. Charge fields, pushing down, weight changes. It's a lot to absorb.
It's definitely not your everyday science, that's for sure. But even if he's not right about everything, he asks the right questions,
Yeah.
makes you think differently about how things work.
Yeah, that's the power of these deep dives. You sent in his stuff, we dig in, and who knows what we'll find.
Always an adventure.
So, listeners, next time you see the moon, think about it. It might be doing more than just shining. Maybe it's messing with your weight just a little. It's a crazy thought, but hey, that's the universe, right? Always full of surprises. Thanks for joining us for this wild ride, and until next time, keep those questions coming.